So Matthew, we would like to get started.
Yeah. Hello, everyone. Welcome to the Bess working group meeting. My name is the disembodied voice that you hear coming from the speakers is Matthew Bocci. My co-chair, Stefan Lukowski, is away at the moment. So Mankamana, our secretary, has kindly agreed to sit at the front and help run the meeting. So this is the note well. I'm going to take a minute for you to look through that. Essentially what it says is that anything you say here is treated as a contribution to the IETF. And we've also been asked to remind you of the IETF's mask policy. So participants in sessions and other IETF control rooms are required to wear FFP2 equivalent or FFP3 equivalent or locally certified equivalent masks. And the only exceptions being for the chairs or presenters who are actively speaking. Participants making comments or asking questions from the floor of microphones are expected to remain masked. And there's a link on the slide if you would like to have a look at the COVID measures at the meeting. So this is the agenda. One change from the published agenda. Ahesh couldn't make it, I believe, so we'll be skipping over his slot. Any other comments on the agenda? Thank you. So now we go into the status update part of working group status update part of the meeting. We have 2 new RFCs published since the last IETF. 9251, which is IGMP MLDP or MLD proxies for EVPN, and 9252, which is the BGP overlay services based on segment routing over IPv6. We have 2 documents in the RFC editor's queue. The EVPN bump procedure updates, which has a misref, it's held for a misref on the EVPN aggregation label draft, and the EVPN optimized ingress replication draft, which is waiting on the bump procedure updates. We have a new AD, Andrew, welcome. And he has a number of drafts with him at the moment, or that are in IESG review. The EVPN IRB multicast draft, the EVPN LSP ping draft. I think, Andrew, you might be waiting for some follow-ups on those. The PrefDF draft is in publication requested state. The virtual Ethernet segment draft is again being followed up by Andrew. The VPWS-FXC draft is in publication requested state, and the EVPN aggregation label draft is with Andrew.
Yeah, thanks, Matthew. Just a little bit of an update from my side. Apologies that there are so many of them. Doing an AD changeover, obviously I inherited some of these things that I'm kind of going back on, which takes a little bit of time. I am following up on these and hoping to move them through. I would say that I think that there are a couple that I'm waiting for follow-up on that I've sent, requests, etc. And that does speed things up if we can get responses quite quickly on that stuff so that we can move the documents forward. But thanks so much.
Thank you. Yes, please respond to any questions from Andrew or comments as quickly as you can. He does have quite a lot of drafts with him, and we did push quite a lot out over the last year or so. Okay, documents under Shepherd's review. The redundant multicast source draft. There were some comments. I think Mankamana's shepherding that, and he provided some comments, and he's going to do the write-up once all the comments have been discussed and closed. The EVPN multi-homing PA draft, Stefan has provided a chair's review, and we're waiting for a write-up from Stefan on that. Draft IETF Bess EVPN Geneve is kind of moving forward a bit now that we've also been moving forward with the EVPN applicability draft in the NVO3 working group. And that's waiting for a write-up from me. The EVPN fast DFT recovery draft, again, is waiting for a Shepherd's write-up from me. And the reason for the delay in that is that we had it took us a very long time to gather all of the IPR responses. So this is kind of a plea from the chairs and everybody's that's working as and volunteering as Shepherds. Please respond to the IPR requests in a timely manner, because we cannot move the drafts forward until we have heard from you one way or another about IPR. EVPN unequal load balancing is waiting for write-up from Stefan. The EVPN IPVPN into working draft. So there's been some discussion on the list. This is in working group last call. And there is comments from one of the IDR chairs on this, and these need to be resolved, we think. So there's some actions on us as the best chairs and on the authors, and to get together with the IDR chairs to sort this out. The EVPN multi-homing split horizon draft, the comments that were on the list appear to have been addressed, and that we think that's ready to move to the next stage now. Currently, we have one document where the authors believe it's ready for working group last call, and I know that this is the BGP SD1 usage draft. I know that we had this on the list to be last called as well at the last IETF. I apologize for the delay of this. We've been deliberately holding back a little bit because of the large number of drafts that we had already sent to our AD to give them time to process those. I think we're going to start moving forward with some more working group last calls and adoption calls after this IETF. So please look out for that. Okay, this is a list of the non-expired working group documents that we have on the data tracker. I think at the next IETF, I'm not going to go through all of these one by one, just a couple of comments. The multicast controller draft, there's been some discussion around how this aligns or doesn't with the with some other drafts in the IDR working group for TreeSID signaling, and we need to go back and look at that draft. The BGP DMZ draft was recently adopted. The multicast flow DF election draft, that's going to expire soon. So authors, please could you just refresh the draft to keep it, if you want to keep it going. I think there may be a few other drafts that have expired. If you wish to keep your drafts moving forward, please remember to refresh them. Otherwise, your working group chairs are getting a bit old, and we will forget about them quite easily. The Yang models, we had an inquiry about what's going on with the Yang models. Generally, due to kind of lack of interest in these and the amount of other work the working group had, we've put these on hold. That decision obviously is you know, we can review that if we have some authors that are interested in driving those forward. Okay, just onto the working group slot presentations now. Just to note, because this is a hybrid meeting, the chairs will mostly be displaying the slides. If anything goes wrong, I think Mankamana is going to try and pick up in the room. Any comments on the working group status update?
So there are two drafts. First, one of the draft per flow DF election that is going to progress by next IETF. So we were waiting on IGNP proxy to become RFC because it uses that draft, that RFC now. And the second one, extended eVPN optimized IR. So today morning I was talking to Wen, and this is ready for working with last call. So we'll move it into the queue.
Okay, thanks, Man Commander. If you can add it to the list on the wiki, that would help us. Thank you. So first presentation, I think, is from Jeffrey. I just need to change my screen sharing over.
Okay, so this presentation, this draft is about transport IP payload or UDP payload only in an IPVPN. The draft started with a pseudowire as a pseudowire draft, and it's just recently rehomed to Bess. This is a collaboration between me and Kier. Next slide, please. I want to start with the use case first. It's for mobile user plane transportation. For 5G, the user or plane or data plane is via a GDPU tunneling, and that tunnel is over an IPVPN. We refer to it as the N3 VPN. The VPN is used just so that a converged transport infrastructure can be used for both mobile and non-mobile related transportations. I have a picture at this end. At the bottom, we can see the Geno B on the left side and the UPF on the right side. Those are the 3GPP and network functions. The GDPU tunnels are between the Geno B and UPF, and that is transported in the N3 VPN. And we have the PEs there to support the VPN. So what happens is that, let's say the Geno B needs to send a GDPU packet to the UPF. It will put on the GDP header, a UDP header, and then finally the IP header, and most likely IPv6 header nowadays. But the packet gets to the PE1 in the N3 VRF, and then to transport that over that infrastructure, a label stack or another SRv6 header is put on. So now, and that's in addition to the original IPv6, UDP, and GDP header. When it gets to PE2, that additional label stack or SRv6 header is taken off, and you expose the original IPv6, UDP, and GDP header. This, I call it MPLS transporting GDP or SRv6 transporting GDP. Next slide, please. There is a draft in the DMM working group talking about using SRv6 to replace GDP. So this we call it SRv6 replacing GDP, not transporting GDP. That is actually still based on the 3GPP's N2, N4 signal, the GDP parameters. So that replacement is done under the hood. As far as 3GPP is concerned, everything is as usual. But now, under the hood, a GDP tunnel is replaced by SRv6. And that SRv6 could be directly between the network functions, or it could be just between the gateways attached to those network functions. Those network functions still do the GDPU tunneling, but the gateways in between will do the translation. So if you go back to the earlier picture, those N3 VPNPs are the natural gateways. The GDP traffic is reconstructed as N3 VPNPs. The IPv6 header, UDP header, and GDP header is replaced with the SRv6 header. This is acceptable to some operators because all these elements are under the same control, operator control. So the advantage of this is that with SR, you can do the traffic steering, and you can do service function tuning, all those wonderful things. And by the way, there is also bandwidth savings now. You don't have the two IPv6 headers and things like that. Next slide, please. So now, when that happens, the information in the GDP header is moved into the SRv6 header. And now, if you're an operator wants to do this, and you're an MPLS operator, and then what could happen here is that instead of using SRv6, you use a label stack, but you transport the GDP header and the GDP payloads as is. You don't need the original IP header or the UDP header anymore. Now, with this, you can, especially if you're doing an SR MPLS, you can have all those wonderful advantages of the SR, the traffic steering and the service chaining, all those things. But now it comes with even more bandwidth savings. Now you do not need an IPv6 header at all. All you need is a label. And that label will tell the receiving router to reconstruct the entire IP header, including the UDP header, based on the information associated with that label. Next slide. Next slide.
Yeah,
Oh, okay. I guess I already talked about this. The inner label in the stack basically tells the ingress router to reconstruct a packet, IP packet with the information associated with that label. So that essentially is a pseudo wire that transports UDP payload only. A control word will be used to prevent transit routers from mistaking the payload as IP. Next slide. That's why the draft was originally put into the as a PALS working group as a pseudo wire draft. But after we start working on the signaling details, we realized that this can be generalized to transport IP VPN traffic without considering it as a pseudo wires. And so it is applicable as long as the traffic are mostly among certain hosts. In the early use case, it's really among the 5G network functions. And also it means that the operator needs to accept that the packets will be reconstructed by the transit devices. If that is not acceptable, then all bets are off. So I want to point out that in this IP VPN, the traffic can be transported in many ways. Some traffic could be transported the traditional way with original IP and UDP header or whatever header. Some traffic will be transported with just IP header removed, and some will be transported with both IP and UDP header removed. Next slide. So for BGP, for signaling, we would use a new CEFI. The NRI will include the label information, a route distinguisher, and destination address, source address, destination UDP port, and source UDP port. Those last three fields, source address, destination UDP port, and source UDP port, those could be wildcards. So those updates will carry the same route targets as VPN, the regular VPN IP routes. The routes will be advertised by the egress PE. Let's say and then based on the advertisement, the egress PE will create a forwarding state so that incoming traffic with that corresponding label will be reconstructed with the IP header. And if you advertise a wildcard or address or wildcard UDP port or things like that, then you have to use the locally configured source address or the source UDP port. And the ingress PE, when you receive the advertisement, it will create forwarding state to strip the IP header or a UDP header as well from matching traffic, and then send the remaining payload with just a corresponding label. Next slide, please. So I appreciate comments. And one question here is just that, do we want to consider other IP payload types, not just UDP, things like that? And yep.
Hi, Greg Mirsky, Ericsson. My question is, you propose it for any type of the user plane or only for 5G?
Indeed, the use case started with the 5G, but I think I alluded to in one of the slides, it will be generalized to any use case where the traffic is mainly among certain hosts, and when it is acceptable for the packets to be reconstructed by transit devices. As long as those two conditions are met, and then it can be used beyond 5G use cases.
Because I think that it's reasonable to expect that 5G services will be introduced in a network that already runs LTE and uses the same GTP. So then the question is whether it would be mixed environment, or you envision that first LTE will transition to this new tunneling and then 5G will join in. And then how these two can be differentiated.
Did you say LTE or OTE?
No, LTE.
Yeah, okay. So I used 5G example, but LTE or even 3G, it's basically the same thing. It's you using the GTPU tunnel among the network functions. I use the 5G terms, but LTE will be the same. Basically, any situation where you have IP traffic mainly among a set of hosts, and you can, it's okay to reconstruct the packets, then you can use this.
I agree with you that it's technically possible. What I wonder is that operator consideration.
So can we take some of the question to the list? I think Hoy is in queue.
Yeah, I saw that you are also using this for the global table in the draft. I wouldn't like to bring up the issue of using route distinguishers and route targets in the global routing table here. But what is the reason why you need a distinguisher and route targets in the global routing table?
So in the initial use case, there is we have the N3 VPN, right? So this is started with the use case in the VPN, and it's natural to use the route distinguisher and route target, things like that. And of course, it can be extended to the global table as well. And indeed, there are some discussions of whether we should use RD or RT for the global table. But at least in my view, using RD, RT for global table could be argued as a feature instead of a bug. But I think that's a different discussion. But indeed, at least if we only focus on VPN scenario, then using of RD and RT is natural and it's required here. We're basically doing IP VPN. It's just that we only transport the payloads with this optimization.
Okay, so you could use the SAFI without or with a zero route distinguisher and no route target, I guess.
Yes, you could do that. Yeah.
Okay. Thank you.
Okay, so this presentation is about an old draft, actually, even before the pandemic. I will not go through the content of this draft. I mainly want to refresh that there is this draft. We didn't do, it was thought before, but I think we will want to move this forward now. So I have some background information to provide. Basically to fix or enhancements some MVPN or EVPN C-multicast route aspects. The C-multicast routes in MVPN and EVPN, they basically carry customer multicast states. For example, MVPN type 6 and 7 and EVPN type 6. It is started as a MVPN term, but generalized to cover EVPN SMAT route as well. It was initially presented in the IETF 96. I included the slides and the YouTube link there. Later on, it was presented again in IETF 104 with additional contents on the MVPN inter-AS multi-homing situation. Again, slides and the YouTube links are there. Next slide. This is basically a snapshot from the table of content. It talks about 5 issues there to be enhanced or to be fixed. Next slide. Next slide.
Matthew is doing.
Oh, okay, all right. So the work has been stalled since 2019. The main reason is that the issues and the enhancements were a bit ahead of the time at that time. And also we can blame the pandemic, I hope. But now it's time to move forward. In particular, one of the issue there about inter-AS propagation of MVPN C-multicast routes, that addresses a main problem in this new draft from Huawei. We had a long email discussion in the mailing list, and I see he has a presentation at the end of this session. Unfortunately, I need to run to another session, so I won't be able to comment there. But there has been a discussion on the mailing list for a long discussion. If you go to the next slide, I think I included a link here. So basically, I would like to move forward with this document, and I'd like to say to put this into the adoption queue. I don't think we need to represent this draft here. I have included links from before, and please review and join the discussion on that is happening between me and Fang Hong on this new draft here.
Any question? Okay, so I see one person in queue. Yeah, please go ahead.
Can you hear me?
Yes, we can.
I'm Fang Hong from Huawei. Hi, Jeffrey. I have a explanation. As I explained in the early part of the mailing list of my document, the objective and solution of my document to be presented later is different with what you have talking about. In my document, it focuses on gaps and solution of MVP using IPv6 infrastructure scenario. So I think that is different than the document that you have mentioned. Thank you.
So there are different solutions to that same problem of propagating C-multicast routes in the inter-AS scenario. It could be either based on the route target constraint mechanism that was discussed in my draft, or it could be addressed using the solution described in your draft. We had quite some discussion there. So I guess we need to convince each other which way is better, or if we should do both solutions or whatever. So that's why I say that if we could, working group members could review my draft as well and review previous presentation, then join the discussion and see what's the best way to go forward.
Thanks, Jeffrey. I think If any other question, I don't see anyone else in queue. Rest we can take it to the list. So next will be Gyan.
So Gans on next, yeah. Let me switch over the.
So just a reminder for rest other people in room that mask is mandatory.
So, Gan, I know you have about 30 slides here and 10 minutes. Can you try and keep to the key slides, please? And just please ask me to move on when you're ready.
Sure, we'll do.
Okay.
We'll do. So, so this this slide deck goes over the IPv6 only P design as well as the IPv4 only P design, all SAFI. There's four drafts in total that we're going to go through. We'll stream through them. The first two, the IPv6 only P design, so that's the initial BCP draft that was adopted in April 21. And then that second draft is an all SAFI, so that supports all SAFIs. And then we have another kind of corresponding draft, which is related to v4. So it's an IPv4 only P design, and that relates to the BCP proof of concept testing, similar to the v6 only P design. And then the subsequent, the last draft is an all SAFI related to the v4 only P design. Next slide. So this slide just kind of goes over the IPv6 only P design, just those first two drafts that I mentioned in the first slide. The first draft was adopted in 2021, and this is the proof of concept testing that we're working with Cisco, Juniper, Nokia, Arista, and Huawei, testing proof of concept of being able to do IPv6 only peering, and it's really focused on three SAFIs. So unicast SAFI, and then SAFI 128 and 129 for VPN and MVPN. The next draft, the IPv6 only all SAFI draft. So that focuses on all SAFIs, and it's really broken up. All the IANA SAFIs are really broken up into three categories. It's so where you have control plane, data plane in line, so like a PEC peering or inter-ASP to PE peering. And then the third category is a controller-based peering. But basically, all SAFIs are supported with that second draft. Next slide. So as far as updates on the IPv6 only P design, we have confirmed that all vendors, so Cisco, Juniper, Nokia, and Arista, and Huawei, sorry, excluding Arista, but Cisco, Juniper, Nokia, and Huawei support there's a vendor specific knob that's required for this, and we'll kind of get into that in detail a little bit. That is required to allow v4 forwarding with without a v4 address configured on the box. So that, and we'll dig into that a little bit in detail. So with this draft, as far as testing goes, so Cisco, Juniper, and Nokia, we're planning to complete all the proof of concept testing by the end of the year, and we'll have that all documented in that draft. And then Arista and Huawei, we're still pending on getting the ETA of completion. Huawei, the plans are sometime in 2023 to complete testing. Next slide. So the IPv4 only P design, so it's very similar. It's similar to the IPv6 only P design, where this is just a V4 single V4 peer, and now we're carrying the V6 NLRI over a single V4 peer. The first draft, similar to the V6 only P design, focuses on three SAFIs, just a unicast SAFI, and then the VPN and MVPN SAFI. And then the V4 only P design, all SAFI, focuses on all SAFIs, and with the same three categories of inter-AS peering, edge PEC peering, as well as controller-based peerings. Next slide. So with this, at a list here, just scope and benefits. So I've listed here just the benefits of the IPv6 only P design. And what I've added in here is just kind of breaking up the three categories of all the SAFIs. So you got the PEC edge peering, inter-AS peering, and controller peering. So just kind of focusing on those three, and that's what we'll be discussing in the next few slides of how that plays. And the big gain is really the OpEx savings here, and that's what I bolded in red at the bottom. Next slide. So this next slide, the difference here is this is the V4 only P design. So the same scope and benefits. The only difference here is with the benefits is you do have an additional possible CapEx savings that you don't necessarily have to actually migrate your underlay to a V6. You could stay on V4 and you're able to carry your V6, as well as you have additional resource savings with the V4 only and not having to have a V6 address and actually the control plane overhead with V6. Next slide. So with the IPv4 only P design, the vendor specific knob. So really the big thing I wanted to kind of mention here, so both the V4 only P design and V6 only P design, the vendor specific knob, it allows for V4 only P design, allows V6 processing to work just as you would have normal dual stack, but without having a V6 address configured on the interface. So basically the interface acts as a layer 3 interface, normal layer 3 hop processing. Everything is actually works exactly the same, but you just don't have a V6 address. And that's where that knob comes into play. So 100% same functionality that you would normally have with a layer 3 interface. Pinging and tracing works exactly the same. The one caveat is you require a loopback. The loopback address interface requires a V6 address on there, and that's just for the ICMP to work properly from the PE. Everything else, IPFix, QoS, ACL, any interface related commands, everything else related to V6 works identically as it would with a standard dual stack architecture. With the V6 only P design, everything is exactly the same as far as the functionality. Basically providing the same with the vendor specific knob for V4 processing without a V4 address configured on the interface. Next slide. So with the V4 only P design, one thing I wanted to talk through in this slide is the next hop encoding standardization. So RFC 4798, sorry, so next, go back one more down. There you go. One more. There you go. Sorry. One more up.
One more. Sorry about that. Okay.
I think you have to go just one up.
One more.
One more up. Sorry.
That's where we were, wasn't
You
it?
just have to go. I think you just have to go one up. I think from there. All right, there we go. That's it. Okay. So here in this slide, I just wanted to mention that. So with the IPv4 only P design, so with RFC 4798 and RFC 4659, they define the next hop encoding as a IPv4 mapped IPv6 address. So with RFC 5549 and then updated with RFC 8950, the next hop encoding for IPv4 NLI over an IPv6 next hop is not a v4 mapped IPv6 address, but it's a v6 address. So 16 or 32 byte for SAFI 1, 2, and 4, and then for SAFI 128, 129, it's 24 and 48. So similar. So in the industry, the implementations have moved away from what was defined in RFC 4798 and 4659 related to the IPv4 mapped IPv6 address, using a 4-byte address for SAFI 1, 2, and 4. It's just a standard IPv4 next hop address, and then as well for SAFI 128, 129, using a 4-byte a 12-byte address, so 4-byte IPv4 plus the 8-byte route distinguisher. So this draft, what it would do, it would standardize that encoding to ensure interoperability with a new IANA BGP code point allocation for that. Just so basically providing the same as what was done with 5549, updated with 8950, providing that same with this draft. Next slide. So here, we're just going to breeze through it. We have a handful of slides we're going to go through, but I'll just kind of peck through this real fast. So what I've done is I've listed all the SAFIs, and they're just categorized. Basically, where I've highlighted CPDP, that's where you have inline control plane, data plane. So that's basically the three categories are PEC peering, NRAS peering, which falls in the CPDP category where they're inline, and then a controller-based peering where it's CP only. Next slide. And then the next two slides, I just kind of list all in color coded, basically just showing that all the SAFIs are supported, providing the same thing where you have either an IPv4 only P design or v6 only. For the v4 only, you just have a v4 address configured on the interface, and you can support all of the SAFIs in those three categories, and then same as well with the v6 only design. Next slide. We can skip through this one, go to the next one. All right, so this slide is just showing just basically two, this is unicast SAFI, just two separate peers. So you got a typical dual stack peering. Next slide. So here we're actually we just have a single peer NRAS, just showing this could be PEC or NRAS peering where you have a single v6 transport peer carrying the unicast SAFI. Next slide. This is another example. So this is showing just SAFI 128, 129, two separate peers, typical dual stack, just giving a visual depiction. And the next slide. And in here, we're just a single peer now, and just now we've got SAFI 120 and 129, both v4 and v6 forwarding. So the same dual stack functionality, everything works exactly the same, but now you're able to really eliminate all of your v4 peering off of the interface. Next slide. Here's another example. So this is showing just the MCAS tree SAFI, which I think we talked about in a previous draft earlier, and then SRTE. So here we have two separate peers. Go to the next slide. And now we got one peer, basically a single v6 peer carrying all three. So you got SAFI 128, MCAS tree, and then SRTE. So just showing the benefits of how this single peer, now you're really able to eliminate all that control plane, having a single peer, and then as well, still got that same dual stack functionality. Next slide. And then this one's a controller-based version. So this is that CP only, where you have, let's say, BGPLS, your northbound interface, and then you have RPD, which is a route policy distribution. So in this case, you have two separate peers dual stacked. Next slide. And now you have a single peer. So now you've got that same controller-based scenario, peering to a PC or SDN controller or BGP controller, BGPLS for your northbound, and then your IPv4 or RPD SAFI. Next slide. This next set of slides, and I'm just going to roll through these, but this is basically doing the exact same thing, but it's with the v4 only P design, and it shows the unicast SAFI. So what I'm going to do is I'm going to skip through to the very end and then just ask any questions. But the next set of slides are the exact same functionality and the exact same slide deck, but it's really just showing the functionality where we're actually doing a dual stack, and then we're showing the single peer. So we can just roll through these. So showing the exact same, but now we're just having a single peer with v4 only P design. So thank you. Any questions or comments or anything related to the four drafts that I mentioned?
Yeah, Jorge, go ahead.
I think in the old SAFI's drafts, I think you're listing some AFI-SAFI combinations that are actually illegal. For instance, the SAFI 65 and 70, so VPLS and EVPN.
Okay.
You're listing AFIs 1 and 2, which are not defined with those SAFIs. So those SAFIs go with API as 25, always, as far as I know.
I said, thank you. Thank you. I'll correct that. Thank you.
Okay, thank you.
Anyone else? I don't see anyone in queue. Thanks, Gan.
All right,
Okay,
thank you. Does anyone else have any questions? Yeah, okay. Thank you.
Okay. Uh,
So next is
Soumya.
Soumya.
Um, am I audible?
Yes.
Sure. Okay. Yeah, so I have three drafts to, so there are two new ones and two which were presented in IETF 113, the last one. So attended to few comments, but these are the two ones which were written in between 13 and 14. So yeah, next slide, please. I'll just go over the next one. I mean, it's okay to skip this one. Yeah. Yeah. So the background of this extension of the LSP ping, the EVP and LSP ping, is all about the comments which or the queries which I had for the base draft for the EVP. And I believe this is not, it's a working group draft. So I've mentioned the old name here. Just bear with me on that. So there were a few queries which I believe were sort of unanswered with respect to the current EVPN LSP ping draft. So as part of that, so there were two options. One to include these extension as part of the initial draft, but the consensus or the advice coming from the authors was to it was too late in the cycle for that draft, so to pen down a new one. So that's the background of how this came to the fore. Next one, please. Yeah. So the queries were all about three unique requirements here. So from so the background here was to draw parallels with the management interface when we are accessing the networking devices. Essentially, it was about the EVP and NRI. So from the operator point of view, just as in a management interface, a partial index can help fetching, let's say, a bunch of entries. So essentially from the OAM side, from the ping side also, it would be easy for a remote OAM access or the OAM ping to be performed with a partial knowledge of the key. Essentially within, let's say if the operator knows about a prefix, which is, let's say, coming from one source, and there are no dual sources known per se. So in that case, all other attributes as part of the EVP and NRI can be foregone. And just the prefix, or let's say a prefix or a MAC and associated parameters, not, I mean, the major ones or the significant ones can do essentially. So that is the ease of usage. That is was point number one. Second thing which drew the attention was since OAM is all about validating both control plane and data plane, um, performing the validations for both ends. So essentially, the requirement is that in few of the scenarios where, let's say, the routing protocol is in a churn or there is a convergence which is happening in place, in that case, if the OAM application is not impacted, then the best bet is to just do a DP validation to ensure the data plane validation, just to ensure the traffic flow won't be impacted per se. And conversely, and the validation just for, let's say, the protocol RIB parameter against the protocol RIB uh, information can also help, wherein let's say there's a possibility that the access to the management interface is denied for few entities, but as a network operator or as an administrator, you need so this is one more avenue to get fetch that information via OAM to get all the OAM specific to get all the control plane specific entries for specific for prefixes, let's say, which may not have made it to the actual forwarding database or to the data plane, right? So that's the validation type check which was suggested to be introduced. Third one is the reachability check to the liaison VRFs. As in, we all have come across the VRFs which don't have any interfaces configured on them, or no subnets which belong to or sourced via them. They're a sort of a liaison VRF wherein the routes are leaked into and the routes are moved out. Let's say the fabric is the outside fabric is EVPN and probably inside it's MPLS or vice versa. I mean MPLS L3 VPN. So in that case, it will be good to have a tighter control to have this liaison VRF, wherein if the liaison VRF is not uh, having any leaked routes, and let's say there is no EVPN tunnel found because of the same reason, for that, for let's say the EVI corresponding to that VRF per se, then in that case it would be good to do a health check via OAM, by explicitly mentioning that in the OAM PDU rather than the corresponding network identifier which may map to an EVI being encapsulated, because in that case the OAM check will be dropped. Uh, Next slide, please. Yeah, this is just one way of showing the overlapping of the parameters, and left side is control plane and right side is data plane. We can skip this here. Next one, please. Yeah, so this is what I was mentioning with respect to the layers in VRF. So we have a border router here in the VXLAN fabric, and then you have an MPLS L3 VPN interfabric extension for L3 extension for that matter. Let's say there is no EVPN DCI which is being done here, or no on the interfabric can be MPLS or VXLAN. So for the wide prevalent deployment, I have shown MPLS L3 VPN here. So right at the border router is where the location of the layers in VRF will belong to, as per this example. And this is where we would need uh, OAM check support for that particular VRF. Yeah. Next, please. So to solve this, there are three TLVs or and a sub TLV which is proposed. Um, First one is the wildcard TLV, which will carry a bunch of a bitmap, which should map to the list of sub TLVs carried in the OEM PDU, the MPLS EVPN ping PDU, to indicate that those fields or those TLVs are sort of wildcard or don't care when the validation has to happen at the other end, at the target end. And the in line with that, or typically wildcard and validation TLV may go hand in hand per se. So the validation TLV is all about picking up the mode, what exactly you want to validate here. Both means the legacy, both control plane, data plane, which will be the default value. And essentially the last one, the EVI sub TLV, is about carrying the EVI or the corresponding fabric mapping of the EVI in the OMPDU. Next one, please. So this is a little description of the wildcard TLV. And let's not go with the type probably if things expand more. I mean, maybe these are wrong descriptions of the type field. But what essentially the sub TLV type indicates is the value, I mean, of the corresponding sub TLV for which we can actually uh, extend this I mean map this particular uh, this new wildcard TLV. But the the most important part is the bitmap. We need to come up with a bitmap per se, wherein the each of the bits in this 32 bit field will map to or should map to one of the sub TLVs which get carried in the OEM PDU. So, and the send side and the receive side are essentially the same thing which I've already explained. So we can hop on to the next one. Validation TLV is again an easy one here. As I explained, what kind of validation we want to do with the parameters or the TLV values which we are carrying in the EVP and LSP ping. So yeah, 0, 1, 2, 0 is the default, and 1 is control plane only, 2 is data plane only. Yep. And next one, please.
Can you move on a little bit more quickly, please? I think we're
Sure. Yeah. Okay. I think this is also, I have explained this. So this is an explicit identifier for the EVI or the corresponding fabric identifier for the EVI to be carried in this, which will map to the, let's say, to the VNI or map to the VRF on the target system, which is alias in VRF. Yeah. And next one, please. I think we are done here. So requesting action, more traction. I have been sending reminders on this since this spawned off from an existing draft. So there was a again, I mean, whether we can merge this to the original draft or whether we should carry on discussing this. Yeah, this is the further actions requested. Yeah, this is it for this one. Any questions?
Yeah, so I see Patrice in queue. So Patrice, you can go ahead.
Hey, hi, can you hear me?
Yeah.
Yes.
I can.
Perfect. Hey, I'm Patrice from Cisco System. Soumya, a couple of things for you. First of all, I went through the draft and there was a comment, like there were 2 comments about the problem statement, which I'm not sure if the problem statement is clearly mentioned, to be honest. One of them was the NLR key is too complex to remember on the actual draft from Parag Jain. That one, I don't understand really that problem statement. And the second one, you were mentioning that there's no IP address available on BCI, so therefore we need to find a different ways. That one neither I don't understand. So can I suggest that you make sure the problem statement is very, very clear stated? You put a bunch of requirement on something that I presume, anyway, I think the problem itself is not that clear. So that's number one. Number 2, the usage of TLV, I'm not sure if you need that. You're talking about bitmap. So to me, it's just a little information with a very complex structure with the TLV. Not sure if you need that. But before, anyway, you go to the solution, I strongly suggest that you restate very clearly that problem statement.
Sure, Patrice. I hope you have gone through the draft in case the slides are not so clear. Yeah.
You know, I read it, but I just, perhaps it's only me, but I'm not getting all the problem statement there, to be honest.
Okay.
Thank you.
Yeah.
Yeah, Jorge.
Hi, Soumya. Yeah, my first comment is similar to Patrice's. Yeah, I didn't understand the justification about the leaking into a VRF for the EVI TLV. So yeah, I agree with Patrice. The second comment I wanted to make is for the wildcard TLV. Basically, the draft allows you to wildcard any field of the existing sub TLVs, if I understood correctly. But I guess you need to put some limitations in the sense that if you want to ping a MAC IP route in the egress P, at least you need to specify the MAC address, right? So it is not that you can wildcard any field, right? So I guess
absolutely,
those.
Yeah.
Okay, so I think those details must be specified. And my last comment is that if you look at the IANA section, you are not requesting for any code point or anything, and you are saying in the TLVs and sub TLVs that could actually be proprietary. That also I didn't understand. If you are writing a draft, in my mind, it's because you are requesting something standard, right? So I didn't understand that part either.
Sure, George. On the INA one, I clarified. I got the notification from the INA team there, and yes, I'm going to clean it up.
Okay, thank you.
Sure.
So somewhere we may have to go a little faster for the next drafts because we are running around 10-15 minutes late.
Oh, okay. Sure. I'll just try to finish off because the last two we don't need to because it's just an update from the last presentation. Yeah, next one. Um,
So Matthew, we don't see your screen anymore. You are there?
Matthew is offline, I think.
Matthew is. Let's give a second. I think he may be rejoining. Okay, his system crashed. So let me see how can I present from here.
Can I
Give me a
share
second.
or?
Yeah, you can share. If you have the slide, please share.
Sure. Um, I have requested actually somebody needs to give me the permission.
Anyone know if Mahesh, by any chance, you know how we can come here? So,
You can't do it from there.
oh,
You have to be on your.
I have to log out and log in.
So, what's this? Okay, which now you permission. Okay, it is. You can't do it from there. Let me.
Yes. Yeah, I'm not able to accept his presentation. Looks like some admin role.
Okay,
Just give us few seconds.
sure.
So Matthew is trying to log in back. It looks like even he is not able to log in.
So, Manakamna, if you can go ahead with somebody in room presenter, then I'm fine. I mean, it's okay.
No, I'm not able to see. No.
It's texted you, I think.
Taking time.
You don't have Ethernet enabled, connected.
He should have given you just the vision and what you got. Because I don't need that vision from
Yeah, this is the Ethernet. Can you connect this to be faster? Okay. Just retry that.
Oh, Matthew is back.
Okay. Got it. Okay, now see you can accept request for the permission.
It is for mine.
And so let it do the test, complete. And now you can go to presentations and sorry.
So Matthew, are you able to present?
Again, I'm back
Okay.
over to G. I'm going to try this way. Just give me a minute. It's saying that all slots for the requested media are already taken, so I don't know what's going on.
So I got a request. Shall I go ahead and say yes, start sharing, or what should I do now? Okay, okay. Are you able to view the? Are you able to?
Yeah, we can see.
Okay.
And you can go to
Sure.
presentation mode maybe.
Sure. Yeah, I'm doing that. Okay. Is it? Are you able to see this?
Yes, we can.
Yeah. So this is about um, marrying two pieces of the technology. Here, it's all about the IP bindings with respect to the network deployments, where the as in the legacy, there would be a significant approval required to let the clients in. I mean, from the uh, in the network per se, right? So from that on, so the L3 clients can also be looked into via various mechanisms, DHCP and the snooping part of it. But but these procedures are very local to the access side of the network, wherein it's between the access switch hosting these IP bindings and requesting for the approval for letting the client packet in with a specific credential, which can be MAC addresses. But in case the network is shared, is extended across the sites, or let's say there is a potential of um, a client moving between the access switches or the wireless controllers per se, then there is a need to synchronize this approval, which has been granted at one access switch, to be synchronized to all others, whether within the fabric or outside the fabric. So BGP control at the helm of it. If in case we have three VXLAN or EVPN provisioned sites, and in this case, you have, I'm just coined them as VTEPs, and you have host 2, host 1 on one of them, and these VLANs are extended across the sites per se. So anything learned via snooped, which is snooped up on the access side of, let's say, VTEP 1, 1, 2, or let's say a VTEP 1, 1, I think something not so right in this diagram, will not be synchronized with each other, and these subnets are stretched beyond the fabrics per se, and there is a requirement to synchronize this approval of client being allowed in the network or the extended network, that needs to be synchronized. um, Essentially, DSCP packets wouldn't be leaked into the fabric, essentially, or should not be leaked into the fabric. More so, we shouldn't be allowing the ND and the R to be leaked over the WAN pipe per se. So these are the three ones. So is local to the client, as I explained, and data packets, which are the DHCP packets, or let's say the relays or the ARP NDs, essentially should be avoided and should not eat up into the WAN pipe. The solution is to synchronized leverage the route type 2, the NRI MAC IP advertisement, by tying it to a new extended community, which indicates that there is a security approval for this particular credential or bunch of credentials being carried in the update messages, and it can be on the destination VTEP, which is also an access switch per se, right, or as part of the uh, first hop router, or first hop switch. I shouldn't say router. First hop switch for the access network. It can be synchronized. So this security approval, or this RT2 based uh, route publishing, can be appended with this new extended community and can be leveraged as a approval which has already happened at the other end of the network. So yeah, so this is what it is. It's a simplistic solution. It's still, I mean, I'm not sure whether there are any parallel solutions already in place per se, as far as BGP control plane is concerned, um, and how it's dealt with at the receiving side, how the security application running over there leverages this information is again implementation dependent, but it's all about carrying this information as part of the MAC update. I understand that since it's extended community, it would be applicable to all the MAC IP updates which are being carried there. But since it's deployed in one campus, and where we expect um, every client to be sorted, or um, allowed to be validated, I think they should fall in place. Yeah, and this is again the client IP, and there can be a sync ID which can be configured at all the VTEPs or at all the BGP peers, which can be validated all across. So this IP binding sync ID is nothing but a instance or a security instance which needs to be in sync across all the VTEPs, and it can be configured via the end operator, and it can be double validated whether this MAC IP binding is for that particular uh, security instance. Yeah. So this can be generalized for all the fabrics, and for all the BGP extensions for VPN, and it can also be extended if not in place for other control plane protocols like LDP, if they are also being leveraged to provision the overlay protocols for MPLS fabric. Yep, and the request is to for the best members to review this draft. And this is what it is. Yeah. Any
Yeah,
queries?
Patrice, you can go ahead.
Hey, hi, Patrice Brissette, Ecosystem. Sonia, I think I'll have similar comment than the previous draft. Make sure the problem statement is very clear. It's not clear, to be honest, so that will be the first things to do. The second part is you're putting a kind of a grouping ID on the assumption this is more secure, but in fact that grouping ID is not even secure, so anybody can pitch in a number. So I don't think you're making it more secure. So therefore, I will strongly suggest you to look at perhaps route targets manipulation or stuff like that, which can do exactly the same job of bringing proper route type 2 to the right router where they can do something meaningful with it.
Yeah, so I mean route targets. Yeah, sure. I'll answer that, but it's in the comments. I mean my thing is route targets are much lower in granularity, which is applicable to, let's say, on a per VLAN basis. Here I'm trying to map all of them to a security instance, which can be mapped, at least mapped per se.
But they are still under VLAN, right? They are still under VLAN. If you perform the HTTP snooping, you're snooping widely. you're going to snoop per specific VLAN or specific interface or a specific broadcast domain. So you're still like bound to a LAN at the end, which is usually your AVI. And from the AVI, you're going to take you can generate your route targets based on that. And then you can even go with perhaps something similar to E3, where you can have different set of route targets that will help you to do that. But the grouping ID definitely will not help you that much, because anyway, you need to import the route. Then you need to look at the grouping ID. So if you're telling me the route targets is too much, well, you still have it. You don't have a choice.
Okay. Yeah, Patrice. Yeah.
Jorge?
Hi. Yeah, my question is, yeah, I don't know if I understood the draft completely, but if this binding ID is the allocation is really out of the scope, and what you do with it when you receive it, it's also up to the implementation. I was wondering if you can use just a regular community or a large community along with the MAC IP routes or anything like that, and then you don't really need to standardize a new extended community, I think. Can you comment on that?
Yeah, George. So, I mean, in this case, we wanted to tie it to the MAC IPs only and keep it restricted, keep it specified rather than leveraging the communities per se. And we wanted to keep it, let's say, a standard tie-up in future evolution where we can extend this particular TLV to carry other parameters as well. Let's say the role can also be synchronized in future per se if the bunch of updates can be carried, and that is also a part of the security update. So having that in mind, it was thought that we can do with uh, a new attribute or as part of the extended community. Yeah. So it's still in the under evolution. I mean, needs to evolve further to carry other attributes. Yeah, that's the answer, John. Yeah.
Okay, but for the current solution, you could actually use any communities, really.
Yes, that can be alternative, but what I meant to say is we wanted to evolve. Maybe I should update it further. This draft, yeah, point noted. Sure.
Okay, thank you.
Thank you. Yeah,
Thinking
for
of move-
these, yeah.
I
Sure.
can share these now, so it seems to be working. So, yeah.
So Matthew, nothing in here. Actually, this is just we have updated with all the comments which we got in the Vienna IETF, and that has been updated. So the all DF bum traffic was an important one where there were comments of, for the actual use case being addressed there, where we wanted all the um, VTEPs in a segment to act as a DF in a case of a distributed active firewalls across the fabrics. So after attending the comments, I haven't heard back from the Bess members who had given that comment. So I'm still waiting there. So I'm requesting them to have a look at the updated drafts here. And that's the update on the first one. And the second one, I have made that as uh, um, uh, informational draft. And yeah, I'm still waiting for, it will help for the Bess members to comment on that as well.
So I see Jorge on queue.
Yeah.
Yeah. Hi. Yeah, for the second one, I have no comments. I think it's a good thing to make it informational because it's really, implementation specific, but it's good to document, so that's fine. For the all P's DF draft, I have a couple of comments. So the first one, so in the past, we already discussed that you were actually requesting a DF election algorithm that it was clashing with an existing working group document that was not code point 2. You changed it to 3, but unfortunately that one is also taken by
Sure,
the
George.
fast recovery draft. So please
Yeah,
change
I
it.
can do it as TBD, George, as of now. Yeah, I can change it to
Yeah,
to be done. Yeah, yeah.
yeah, that is probably better. Thank you. And my last comment is that the DF election that you are proposing is okay. It's just proposing that all the Ps in the Ethernet segment can forward bump traffic. But then in the draft, you are making some assumptions about the way the remote Ps are sending traffic to those firewalls. And that is the part that I'm missing. I'm still missing, and I don't understand what you are doing there. So probably we need more discussion in the mailing list.
Sure, sure, Joe. Sure, Joe.
Thank you.
Yeah.
Patrice, it will be quick comment because I think we are really running out of time.
I need 20 seconds. So Patrice Brisset, Cisco System. For the first draft on the all DF band, Sonia, there's already another draft which is bringing the single flow active load balancing mode. It is exactly doing what you're trying to do. And I think the way you put it in the draft is wrong because your ESI is wrongly assigned to the proper device on the network. But please have a look to the L2 gateway protocols draft. For the second one on the dampening backoff, I will strongly suggest you that you go over the EVPN IRB extended mobility draft from Niraj Malhotra. It will solve your issue. Thank you.
Okay, sure. Thank you, guys. Thanks a lot. Yeah.
Hello. Can you hear me?
Yes, we can.
Okay. My name is Fang Hong from Huawei. So this slide is about the MVP gaps and solutions in gaps and solutions of MVP used in IPv6 infrastructure threats. Next slide, please. Oh, sorry. Makama, I have sent you the new slides this Monday morning. Can you open that one?
This would be the one which updated over weekend, I think, not today.
Okay. This is the first presentation of the document. I was published before IETF 112. I requested a slot in IETF 113, but missed the presentation because of the problem of microphone. I started a mailing list discussion in May of this year, and there is a long thread of technical discussion. Here, this is the main problem. Long segmented inter-AS tunnel establishment procedure, which defined in RFC 6514 and RFC 6515, faces some problem in IPv6 infrastructure scenario. In the regular MVP procedure of RFC 6514, LIFP send a long segmented inter-AS semantic routes using the originator IP of the root P to fill the source AS field of LI, and SBR control the semantic propagating between AS along with the reserve path of intra-AS-AD using RD and sources of semantic LI to match against RD and originator IP of corresponding intra-AS-AD. The problem is that the sources field of the semantic LI is 4 byte length, cannot hold IPv6 originator IP in IPv6 infrastructure scenarios. Next slide, please. Here is the proposed solution. For the propagating control between ASs, SBR still controls the semantic propagating along with the reserve path of inter-ASAD. Still use RD of semantic NORI matched against RD of corresponding inter-ASAD. The modification is that the global administrator field of IPv6 semantic import RT is instead of source S field of semantic NORI to match against the originator IP of the corresponding inter-ASAD. So the solution is compliant with the regular propagating procedure in RFC 6514 with the only modification to adapt the regular one to IPv6 infrastructure scenario. It is an endogenous propagating mechanism of MVP. It should be noted that to do precisely extracting of the semantic import RT on SBRs, the local administrator field should be filled with non-zero value even in GTM scenarios. Next slide, please. If there are only one root P for specific multicast source, the solution in the previous slides is enough. Here is a scenario that a specific multicast source multi-homing to multi-routing Ps. The long segment inter-AS semantic root must be distinguished for each individual root P. There are three options. Option 1, each root P configured with distinct RD, which is recommended in RFC 6514. Option 2, each root P configured with a distinct 4-byte MVP distinguisher to be used to fill the source S field of semantic NORI. Option 3, all leaf P use a common hash algorithm to calculate the 16-byte root IP to a 4-byte Unicode distinguisher to fill the source S field of the semantic NORI. Option 2 and option 3 are used in the scenario of all ingress P configured with SIM-RD, GTM as an example. In this document, the source S field in semantic NORI is renamed to a root distinguisher field. The renamed to root distinguisher. Next slide, please. Here is another problem. In the progress of evolution to IPv6, IPv4 and IPv6 infrastructure stress will coexist in the provider's network. The following figure is an example of BGP MVP evolution to IPv6. IPv4 and IPv6 parallel BGP sessions are established, and the number of the passes of these routes will be doubled with each reflection. Next slide, please. Here is a proposed solution to reduce BGP MVP routes in parallel IPv4 and IPv6 BGP session networks. The following action should be taken by sender PEs. For intra-S IPMS-AD routes, SPMS-AD routes and leaf-AD routes, if the originator router's IP address field in the route is filled with the IPv6 address, it is sent to IPv6 BGP neighbor, otherwise it's sent to IPv4 BGP neighbors. For intra-AS IPMS-AD routes and source active AD routes, it is sent to both IPv6 BGP neighbor and IPv4 BGP neighbors. For semantic route, if the IPv6 VRF route import external community exists in the route, it is sent to IPv6 BGP neighbors. Otherwise, it is sent to IPv4 BGP neighbors. In the reflector routers, the part of routes which are received from IPv6 BGP neighbor will be reflected to other IPv6 BGP neighbors, and the other part of the routes which are received from IPv4 BGP neighbor will be reflected to other IPv4 BGP neighbors. Next slide, please. Next slide, please. If you have any comments, we can continue to discuss it in the mailing list. I think the issue and the solution described in this document is clear and comprehensive. So I want to initiate adoption call this time. That's all. Thank you.
Okay, let's just comments to the list, and we'll move on to the next one, please.
Yep. Someone is laughing, or
I think it's Fang Hong, I think you're breaking up.
Some noise. Okay. Hello everyone, I'm Heng Wang from Huawei. Next slide, please. Yeah. This draft was presented in last IETF conference and was refreshed a little bit, so I will talk it in brief. RFC 9026 brings out the concept of cold, warm, and hot route standby, and also defines downstream P's UMH selection based on P-tunnel status for MVPN fast failover. But in some use cases, determine the status of a P-tunnel is unavailable for a downstream P as listed on the slide. So we think it could be feasible for the upstream Ps to participate more for the failover. Next slide, please. Next slide, please. Okay. We hope to use some existing methods for the selection. Take the VRIP, for example. The roles of the VRIP routers can be mapped to the MVPN dual homing upstream Ps. So both the primary and the standby Ps install VRF PIM state from BGP's multicast routes and send join to customer source direction. When the traffic arrived at both upstream Ps, only the primary one forwards the flow into the P-tunnel to downstreams. The VRIP is just one solution. Other private implementations would be optional. Okay, next slide, please. Or next one. The downstream Ps still need to advertise a standby multicast route described in RFC 9026. However, the standby PE community is no longer necessary because the upstream Ps can decide their primary or standby roles by themselves. Downstream Ps then accept the C flow from any of the candidate upstream Ps and forward it to CEs. It's a kind of any-cast RPF checking. The C flow duplication in backbone will be prevented by the upstream P's DF selection as mentioned above. Also, next slide, please. We are seeking for more comments and discussions. or we may talk it in the mail list.
Okay, thank you.
Thank you.
Please read the draft and those comments to the list. Next up is Eng. Go ahead, please.
Can you hear me?
Yes.
Okay. Hello, everyone. My name is Zheng Fu. I'm presenting the draft about L2VP PWS stimulus with EP PWS over SRv6. Next slide, please. We're going to talk about the first things here. The first part is instruction about what the solution is in the draft, and we will briefly talk about the program, what we will solve up, and the solutions that we are defining in the draft, and then the next step. Next slide, please. This draft provides a solution for migrating L2 VPN VPWS to Internet VPN VPWS over SRv6. The main requirement is how to identify whether the software of the VPN VPWS SRv6 is same with the software of L2 VPN VPWS. Next slide, please. The migration procedure in draft Bess VPN VPWS stimulus is as shown in the figure. The first step, the both P act as a rule of the latency PE. They send the LDP message or VPWS AD routes with the IPv4 address. The second step, the P1 upgrade to ComSat PE, and it will send the ePIN Internet AD per EVI route with the IPv6 next hop address. The third step, the P2 upgrade to the ComSat PE, and it also will send the ePIN Internet AD per EVI route with the IPv6 next hop address. Then the last step, the P1 or P2 should select the ePIN Internet AD per EVI route high priority and may bring the LVPN software operation down, as stated in draft reset Bess ePIN VPWS stimulus. However, how to identify whether the latency software is the same with the ePIN VPWS? In the SRv6 scenario, the next hop of the ePIN Internet AD per EVI route is an IPv6 address, which is different from the source address of the LDP message or the VPWS AD route. As a result, maybe PE bring the wrong LVPN software down. So next slide, please. The draft provide a solution to identify the latency software and the ePIN VPWS, whether is from the same range. The solution defines a new extended community attribute and add the new community in ePIN Internet AD per EVI route. When the ComSat PE send the ePIN Internet AD per EVI route, it obtains the source address of the LVPN VPWS. And the P1 must send the ePIN Internet AD per EVI route with the L2 VPN VPWS orange IP extended new community attribute. Then the other ComSat PE receives the ePIN private AD route with the new extended community attribute. The PE gets the value of the L2 VPN VPWS orange IP from the extended community. The PE will check the value of the L2 VPN VPWS orange IP and whether it's the same with the source IP address from the received LDP message or VPWS AD route. If the result is the same, which means the ePIN Internet AD route from the same PE, the PE may bring the L2 VPN pseudoware operationally down and should select the correct ePIN Internet AD private route high priority. Next slide, please. So the next step for this draft is basically we are seeking the more feedback. That's all.
Yeah, Patrice, go ahead.
Hey, hi, Patrice Risset, Cisco System. First of all, thank you for the draft. Second though, as you know, there's already the seamless, the seamless draft that I carry since a couple of years, where we are already shipping and have co-author from various also providers. So may I suggest that we should look definitely at the solution. I'm not convinced this is the right one, by the way, but the problem is real. So we should look at the solution, and I will strongly suggest that we enhance the current draft that everyone has already adopted for the seamless. Thank you.
Pardon?
Yeah, so if comment was not clear, maybe you can send in the list as well, Patrice.
The comment is very simple, is I strongly suggest that we enhance the current seamless draft that we have already for VPWS. The problem is real. I'm not sure about what is suggested here is the right solution, but definitely a solution must be proposed, and it should be part of the one that everyone's are co-authoring.
Oh, okay. Okay.
Yeah, so, hi.
Yeah, I kind of agree with Patrice. So the solution is in the EVPN VPWS seamless draft, although it's hidden, so it has to be made explicit. And there are different solutions we could think about. You could even think about using the an IPv4 next hop on the SRv6 route that you can easily compare with an IPv4 next hop from the pseudo-wired route, or the other way around, you could use the same IPv6 address because this is normally for migration purposes. And even if you wanted to define a way to identify the origin PE, we have an old draft that defined the originating PE. It was at the time was used for InterAES option B, and we could actually resurrect that draft because it really makes sense to generalize the identification of the PE if it is needed. But again, it has to be discussed in the context of this EVPN VPWS seamless draft. Thank you.
Okay.
Okay, any other comments?
I don't see anyone else in queue.
Okay, great. So with that, I think we are done.
Yeah, anyone else in the room, any comment? Yeah, that's all, Matthew.
Okay, thank you very much, everyone, and see you in London.
Thank you.
Thank you.
Huh?